side and side angle side, and these are going to be congruence postulates. So the first one is side, 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 and the second one is side angle side. So basically it says that if three sides of one triangle are congruent to the three sides of a second triangle, then both triangles are congruent. So from here we can say that the congruence statements that exist would be something like, if we just look at the segments, SU is congruent to BO. We also know that SN, and I'm looking at the hatchings right here, right? And I know that SN is going to be congruent to BW. And then finally, I know that UN is going to be congruent to OW. So with that in mind, I can now say that I have the congruent statements for the triangles. So triangle SUN. So look at the direction that I'm going in. Let's draw that out. I'm going SUN is going to be congruent to triangle BOW. BOW. You have to have the same direction. So now we're going to look at side angle side, and this basically says that if you have two sides and the included angle of one triangle that are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So you're saying that you have a side, and an angle in one triangle, and a side, and an angle in another triangle. Those two sides correspond with each other and they're joined by one angle. So now you have the side angle side postulate. The theorem that we can say says that we're going to need two sides joined by an angle. Right? So that means here are my congruence statements. I have angle or side 1. So we use these hatchings, remember? So I have QP and TS. So segment QP is congruent to segment TS. That's my first statement. And then I have a second segment, so QR, because I have two hatchings. So now I can say that QR is congruent to TU. And then lastly, I'm going to say that angle Q is congruent to angle T, because you have that symbol right there. So now this means that triangle PQR is going to be congruent with triangle STU, because you had side, angle, side. All right, so let's look at the examples. The symbol that we need to learn today is going to be the not congruent sign. So it's a congruent with a null inside it. So again, this means not congruent. Okay, so first, triangle. Do we have enough information to prove that triangles are congruent? We're going to start with triangle ETA. So I have a side and another side, and then I have another triangle. So this works out actually. So if I look at the same starting point, I went ETA, I came back this way. So that means I'm going to go AKE. And so I have two sides that correspond with the other two sides. So I have triangle, remember the order matters, AKE. So this is side, 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 because they share the third side. All right, it says Eric has 4 congruent sides. Okay, so if I have triangle RIC, look at the direction. We have R congruent with, RI is congruent with RE, and then I can also say that IC is congruent with CE. Okay, so now I have triangle ETA, and I have triangle EAE, but it already has the markers on there. So ETA has an angle and a side. So unfortunately here, this doesn't have any congruency. It's not even for side angle side because I would need a second side. So there's no second side. So it is a not congruent. Okay, next. All right, I have RK. So RK bisects BC. So that's perfect because now you have a midpoint. So now I say BIR, let's use a different color. BIR is going to be congruent with CIK. So CIK, and what do they have in common? Let's erase this. What do they have in common? What I see that they have in common, not only do they have sides in common, but they are the side, each side is joined by an angle. So this makes this one side, angle, side. Okay, next, remember we have to have an angle in common. So I have a leg is congruent to a leg, and then I have an angle that's congruent, but I'm missing a side. So I'm missing a side. So this is not congruent. I didn't even need to look at the triangle on that one. Okay, so this one is a little bit different. So I see a side and I see an angle. I see two angles. That's good. And then they share a side. That's even better. So remember that the angle has to join the two different sides for each triangle. So AD is a bisector of SAF. Okay, so let's trace the triangle. If I trace a triangle, I'm going to get ASD. So if I trace a second triangle, it's AFD. So triangle ASD is congruent to AFD by side, angle, side, because I had that shared angle. All right, so next one, triangle SSS TA, I'm missing a side, so I'm missing a side, so this is not congruent. Okay, let's look at KRO. So triangle KRO, I have two sides and I have a shared third side, so then that's going to be by side, 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 and we have to go in the same order for the corresponding, so it's going to be OCK. OCK. Alright, and the last example, A is the midpoint of RG. So midpoint makes segments equivalent. And I know that these are both right angles, and they share a side, so that's your second segment. So side, angle, side, side, angle, side, side, angle, side. Now you need to look at the order. Let's pick a different color. I went triangle RAD, so that means I'm going to pick triangle GAD. So this is GAD.